Hello and welcome. Today, we'll examine how sample size affects statistical measures, dive into hypothesis testing, explore significance in both statistical and practical terms, and understand analysis of variance ANOVA in educational settings. Let's start with the concept of sample size and its impact on statistical measures. When we increase the sample size from a smaller study, such as one with 40 subjects, to a larger study with 200 subjects, several things happen. Firstly, the t value, which is a measure used in hypothesis testing, is likely to go up. This is because larger sample sizes tend to provide more reliable estimates of the population parameters, reducing the standard error and increasing the t value. Conversely, the p value, which indicates the probability that the observed results are due to chance, is likely to go down. Larger sample sizes generally lead to more precise estimates, making it easier to detect significant differences if they exist. However, the effect size, which measures the magnitude of the difference between groups, is likely to stay the same. Effect size is independent of sample size and reflects the actual difference in the population. Now let's discuss hypothesis testing. When we perform a t-test, we often have a critical value that helps us determine whether to reject a null hypothesis. If the hypothesis being tested is directional, it means we are looking for a specific direction of effect, such as whether one group is greater than another. This is opposed to a non-directional hypothesis, where we are simply testing for any difference without specifying the direction. The level of significance, denoted by alpha, is the probability of making a type 1 error, which occurs when we incorrectly reject a true null hypothesis. This is a crucial concept in statistical testing because it helps us understand the risk of false positives. On the other hand, the power of a study is the probability of correctly rejecting a false null hypothesis, which is related to making a type 2 error. High power means we have a good chance of detecting a true effect when it exists. Moving on to the concept of significance, we differentiate between statistical significance and practical significance. Statistical significance refers to whether the observed effect is unlikely to have occurred by chance, while practical significance considers whether the effect is large enough to be meaningful in real world terms. This distinction is important in both B to 12 education and higher education, where we often need to consider the practical implications of our findings. In the context of ANOVA, we refer to it as an omnibus test because it tests all possible null hypotheses simultaneously. This is particularly useful when comparing multiple groups, as it allows us to determine whether there are many overall differences among them. After performing ANOVA, we may conduct post hoc tests to explore specific group differences further. These tests are performed after finding a significant result in ANOVA and help us pinpoint where the differences lie. Let's consider an example from B to 12 education. Suppose a school district wants to compare the effectiveness of three different reading programs. They conduct a study where students are randomly assigned to one of the three programs, and their reading scores are measured after a semester. The independent variable in this study is the type of reading program, while the dependent variable is the reading score. The ANOVA test would help determine if there are any significant differences in reading scores among the three programs. If the ANOVA result is significant, post hoc tests can be used to identify which specific programs differ from each other. In higher education, a similar approach can be used to compare different teaching methods. For instance, a university might want to compare the effectiveness of traditional lectures, online courses, and hybrid courses. Students are randomly assigned to one of these methods, and their final exam scores are measured. Again, the independent variable is the type of teaching method, and the dependent variable is the exam score. ANOVA would help determine if there are significant differences in exam scores among the three teaching methods, and post hoc tests would identify the specific differences. Now let's discuss the concept of degrees of freedom, which is a key component in many statistical tests. Degrees of freedom refer to the number of values in a calculation that are free to vary. In the context of ANOVA, the degrees of freedom for between group variation are calculated based on the number of groups being compared. For example, if we have three groups, the degrees of freedom for between group variation would be 2. Another important concept is the p-value in ANOVA, which indicates the probability that the observed differences among group means are due to chance. A low p-value suggests that the differences are unlikely to have occurred by chance, indicating a significant effect. To summarize, understanding these fundamental concepts in statistics and research methodology is crucial for interpreting and conducting research in education. By grasping the principles of sample size, hypothesis testing, significance, ANOVA, degrees of freedom, and p-values, you will be better equipped to analyze and understand research findings. Thank you for your attention, and I hope this lecture has provided you with a solid foundation in these important topics. If you have any questions or need further clarification, please feel free to ask.